Good morning students, welcome to the class. My name is Deepak Kumar. In today's session we are just gonna to discuss the Pythagoras theorem. Okay students, in today's session we will discuss that how can we prove the Pythagoras theorem. Pythagoras theorem is quite important for the students who are just pursuing their 9th class and their 10th also. In addition to this theorem is quite important for the students who are just preparing to get any government job like SSC, CGL, CHSL, CPO and CDS. Understand that? So students, we will discuss the Pythagoras theorem. As we know, what is Pythagoras theorem? If there is a right angle triangle, then a square of the hypotenuse will be equal to sum of square of other two sides. Means a square of the hypotenuse will be equal to a square of perpendicular plus a square of base. So we have to prove this. Okay, here are the conditions given. Is that there is a triangle ABC is given. Okay, angle be equal to 90 degree, angle be equal to 90 degree. This is already given. Okay, and we have to prove AC square equal to AB square plus BC square. AC square equal to AB square plus BC square we have to prove. Okay, to prove this we have to do a construction. So construction is that BD perpendicular to AC, BD perpendicular to AC is drawn. So it is drawn BD perpendicular to AC. Now what is the proof? We are going to prove it. Okay, firstly we will discuss the things about triangle ABD and triangle ABC, triangle ABD and triangle ABC, and we have to try to prove these two triangles similar. Okay, can we say these triangles are similar? So what are the conditions of the similarity? Side side side, side angle side, angle angle side, angle angle angle. If all three angles of two given triangles are equal, those two triangles can be said similar triangles. Okay, so I can say that in triangle ABD and triangle ABC, angle A is common, angle A is common. So I can say students, angle A equal to angle A. Why equal? Because common. Okay, now I can say angle ADB, angle ADB equal to angle ADB equal to angle ABC, angle ABC. Why? Each angle equal to 90 degree, each angle is equal to 90 degree. Now I can say that if value of this angle is A, this angle is 90, then this will be 90 minus A, this angle will be 90 minus A. Okay, in triangle ABC, this angle is B, angle B is 90, this is already 90 and this is A, so I can say that this angle again will be 90 minus A. So, and this is also the rule, if two angles of two different triangles are equal, then third angle will be equal automatically. Okay, so I can say that angle ABD will be equal to angle ACB. Okay, so now we can say that these two triangles are the similar triangles. I can say that triangle ABD similar to triangle ABC, So we have proved these two triangles similar. Now what is the results, outcomes of the similarity? Similarity says that if two triangles are similar, then ratio of their corresponding sides will be equal. Ratio of their corresponding sides will be equal. So firstly we will start from triangle ABD, because triangle ABD is written at the first place. So in the condition here we can say that we have to prove AC square equal to AB square plus BC square. So square of AB is used here. So firstly we have to take side AB. So in triangle ABD, side AB is opposite to 90 degree, side AB is opposite to 90 degree. Okay, so we can say that AB upon, now see in triangle ABC which side is opposite to 90 degree angle. In triangle ABC, angle B is 90, so side opposite to this 90 degree angle is AC. So we can say AB upon AC will be equal to, now I will use another side which is equal to 90 minus A angle, 90 minus A. So firstly we will start from triangle ABD. So side opposite to this angle 90 minus A equal to this is AD. So we can say AD upon, in larger triangle ABC, Side opposite to this 90 minus a is AB. We can say AB. Now just cross multiply. We can say that AB square equal to AC multiply AD, and this is equation number 1. This is equation number 1. Okay, this is equation number 1. In the same way, we have to prove remaining two triangles. Means now we have to prove triangle BDC similar to triangle ABC. Okay, so we are moving on next page, and we will try to prove these two triangles similar to each other. Okay, I am drawing the picture diagram over here again, so we can understand the things in better way. So this was the triangle ABC. Okay, angle B was already given 90 degree, and a construction was done by us that BD perpendicular AC is drawn. Okay, BD perpendicular AC is drawn. So what we have to do now, we will try to prove congruent to triangle BDC and triangle ABC. And now this time we can say that, students, that angle C will be the common angle for both the triangles. So angle C will be equal to angle C, common angles. Okay, common. Understand that? In now we can say that this angle BDC will be equal to ABC. Angle BDC will be equal to angle ABC. Why equal? Each angle equal to 90 degree. Now third remaining angle will be automatically equal. So we can say that this angle will be equal to this angle. So I can say angle DBC will be equal to angle BAC. Okay, so if three angles of two different triangles are equal, they are known as similar triangles. So we can say that triangle BDC similar to triangle ABC. These two triangles are similar, and we know the outcomes of the similarity. If two triangles are similar, the ratio of corresponding sides will be equal. Understand that? So we will try to apply the congruent outcomes of the similarity over here. I can say that we are starting from triangle BDC. We can say that in triangle BDC, side opposite to 90 degrees BC. So we can say BC upon. In triangle ABC, side opposite to 90 degrees AC. So we can say BC upon AC equal to. Now in triangle BDC, side opposite to this particular angle. Okay, this angle is CD. So we can say CD upon, again, side opposite to this angle in triangle ABC, because this and this both are equal. So side opposite to this angle A equal to BC. Okay, now after doing cross multiplication, we can get that BC square equal to AC into BD, AC into CD. Okay, AC into CD. This is equation 2. Okay, now what we are going to do, we have to add both the equations. The equation 1, this is equation 1, AB square equal to AC into AD, and equation 2 here. This is equation 2. So add equation 1, and equation 2. Okay, add equation 1 and 2. So we can say that AB square plus BC square equal to AC into AD, AC into AD plus AC into CD. We can say that AB square plus BC square equal to, AC is common, students, so we can say AD plus CD, and we already know that AD plus CD equal to AC. So we can say that AC multiply AC. Okay, students, AC multiply AC. So we can say that AB square plus BC square equal to AC square. So this was the proof of Pythagoras theorem. Understand, students? This was quite simple proof related to the Pythagoras theorem. Okay, so stay tuned with me and try to share these videos if you found these videos beneficial to yourself. Okay, so share these videos with others so others can get the benefit of these concepts. Okay, so all videos will be available here on this channel, but thoroughly in English, not in Hindi. Understand that? Thank you so much, students.